Traditionally, most of what we know about sea turtles come from the nesting beaches. That's where we have easy access to the animals. Females come up on these tropical beaches and lay their eggs in warm sand, and the female green sea turtle, for example, will lay about 100 ping pong ball size eggs, and she may lay 2 to 8 nests within a season. However, the number of nesting females on a nesting beach is not always a good measurement of the overall health of a population. Today, conditions on nesting beaches are changing, and we're seeing a general trend of warming now. One of the really interesting things about sea turtle is that their sex is determined by the incubation temperatures of the eggs, with cooler temperatures producing more males and warmer temperatures producing more females. With only a few degrees can really alter the sex ratios of turtles' hatchlings.
We don't know a lot about sea turtle sex ratios, so it's really important to get that data to help us determine the abundance of the population, the sex ratio, the survivorship of different sexes. But figuring out the sex of sea turtles is not easy.
One of the big challenges that we have is that there's no physical characteristics that can be used to determine the sex of a sea turtle until it reaches sexual maturity, which is when the males develop a longer tail than the females. Most studies rely on measuring the temperature of nests to estimate the sex ratios that would have been produced given those temperatures. Another approach is to look at the sex ratios of sea turtles at a foraging ground.
The foraging grounds give us a unique opportunity to look at the overall population, because it's many years of different turtles being born on different nesting beaches which come to these foraging grounds. So you have immature turtles, which can be anywhere from 2 to 20 years old, and then you have mature turtles, which are generally 25 to up to 50 years old.
So this work is done in strong collaboration with the Australian government and the Queensland Parks and Wildlife. And the foraging ground that we studied is called the Howard Group. It sits in the northern part of the Great Barrier Reef. And from previous research we've done, we know that 90% of the turtles originate from the 2 Great Barrier Reef populations, with roughly a 50-50% split. So a typical day in the field, we catch somewhere between 70 to 100 green turtles in a day. After the turtle is caught, we take it back to the boat, we measure and tag it. We also take a blood sample that we use to find out whether it's a male or female. And then we take a small tissue sample that we use for genetics to find out which nesting population these turtles belong to. What's quite unique about what we're doing is that once we apply the genetics and we can estimate the nesting origin of these turtles, we can actually calculate nesting population-specific sex ratios for different size classes. So one of the surprising things that we found in this study was that the overall sex ratios at the foraging ground wasn't that alarming. It was slightly female biased. But it wasn't until we applied the genetics that we saw that the turtles coming from the cooler southern nesting beaches were only moderately female biased, with about 65% female. However, the turtles coming from the warmer northern nesting beaches, we found this extreme female bias of 99% or more females in the young turtles, which means that virtually no male turtles were born from these nesting beaches.
So this information was unknown until now. Nobody's combined these techniques before to figure this out. And most sea turtles reach sexual maturity around 25 years old. And the immature turtles that we examined for this study are probably at least 5 years old. So we're thinking that we'll start to see this feminization of the populations coming into full effect in about 20 years from now.
However, a few male turtles really goes a long way. Because male turtles are polygynous, which means that they can mate with several females. It's important to remember that they've been around for 100 million years, they've outlasted the dinosaurs, and they've adapted to a changing climate through that whole time. However, the climate is changing faster now than it has ever. And so the questions that we're all asking is, will it be able to adapt, and will it be able to adapt fast enough? And I certainly hope so.